All right, these are your notes for your red book, chapter 6.4. Describe the kind of data you can display in a bar graph is your essential question, and your title is bar graphs. You have two vocabulary words you'll want to look up and define: bar graph and double bar graph. A bar graph can be used to display and compare data. A bar graph displays data with vertical and horizontal lines. Your key word here is compare data, okay? It just compares two things, or maybe three, or maybe four. Example 1A, reading a bar graph. Which biome in the graph has the least average summer temperature? So you go over to your bar graph, you look for the shortest bar, and that is our coniferous forest, and that is our answer. You find the lowest bar, and coniferous forest is the answer. Which biomes in the graph have an average temperature of 30 degrees Celsius or greater? Now you have to look at the bar graph and find whose bars measure 30 or more than 30. And you see that grassland and rainforest are both at 30 or higher. Which biome in the graph has the highest average summer temperature? Now you're just looking for the highest bar. The rainforest has the highest average temperature. Which biomes in the graph have an average summer temperature of 25 degrees or greater? And the answer would be anything that is at 25 or higher, which would be deciduous forest, the grassland, and the rainforest. Use the given data to make a bar graph. So you're given a table and you need to make a bar graph. So the two things you're comparing here is grade level and the number of magazine subscriptions sold. So since we're comparing two things, we can make a single bar graph. Now your step one is to find an appropriate scale and interval. The scale must include all of the data values. That means your scale is what numbers need to be on the graph. If you put a graph of 1 through 10, that isn't going to cover any of our numbers because all of our numbers are over 200. But you also don't want to just do from 1 to 300 because that still won't include everything. It also would be a whole lot of work to put a line on your graph for every number from 1 all the way up to 600 to be able to get all of our numbers on there. So your interval separates the scale into equal parts. In this particular case, it might be beneficial for us to go by every 100 or maybe every 50. Use the data to determine the length of the bars. Draw your bars of equal width and the bars cannot touch. You don't want to make one bar wider than the other because it makes people think that one's more important for some reason. Make sure you put a title on the graph and you label your axes. Excuse me. The title is important because that's how you know what it is. Magazine subscriptions sold. And if you don't label your axes, you don't know what the things you're comparing. So you should have grade on one side and number of magazines on the other. And here you are. You have your title, magazine subscriptions sold. You have subscriptions on one side, grade level on the other. Each one of your bars is labeled. And you can see that their interval, they went by 100. So they have 0, 100, 200, 300, 400, 500, 600, 700. You always want to go a little bit higher than your biggest number so that your highest bar doesn't touch the edge of the graph. And they also have a full scale that's big enough to show all the graph. That's their scale. Use the given data to make a bar graph. Here's your chance to make one. There's your steps. Did you make it right? A doubled bar graph shows two sets of related data. So for example, a lot of times you'll see a split between boys and girls, men and women. You might see in this case, based on grade level, 6th graders and 7th graders who are in art, music, or science club. Those will work as well. It's comparing two things, but then comparing two things, but taking one of them and splitting into two. So in this case, I could have told you all the students that are in art, music, and science. In this case, I split it up in boys and girls. All right, so here's our graph. We're going to determine the appropriate scales for both sets of data. So in this case, we need to go all the way up to 18 so that our science club for boys didn't run off the side of the graph. Use the data to determine the length of the bars. Draw the bars of equal width. Bars should be in pairs. Notice the orange and purple bars all touch, but the science bars don't touch the music bars. And then we also have a legend to label boys and girls, because you're not going to write boys and girls, boys and girls, boys and girls under each column. That's why you use a key. Now here's your chance to make one. Okay. All right, let's do a quick quiz to see how you did. Use the bar graph to answer each question. Which animal was the least popular among students? You want to find the smallest graph or bar, and that would be, you're right, bird. Which pet was more popular to twice as many students as rabbits were? So this question's got two different things. Rabbits, you have to figure out that. Rabbits is halfway between 4 and 6, so it's going to be 5. What's twice rabbits? Well, 5 times 2 is 10. So which pet was more popular to twice as many rabbits? So more popular than rabbits, and twice that would be dog, because dog is at 10. Make a bar graph of this data. 6, 2, 2, 3, and 3. So remember, the first thing you want to think of, what does my range need to be? My biggest number is 6, so I better go a little bit higher than that so that 6 doesn't run off the bar graph. And in this case, do I want to count by ones, tens, hundreds, fives, twos? Well, my range is only 4 because the difference between 6 and 2 is 4. So I probably want to go ahead and count by ones because my numbers aren't very spread apart. And there's my data. We go a little higher than 6, we counted by ones. And in this particular graph, they included a legend, but it's not necessary since it is just a single bar graph and you already have the labels along the bottom.